Welcome to File 7. This is the last of the risk return videos. It's on investment analysis and optimum portfolio of two stocks, but easily could be two subsidiaries or a company or two product lines, but for consistency with your textbook, we're going to look at it as two stocks. In this video, what we're going to do is we're going to be looking first at the risk and return of specific stocks, meaning the standard deviation and mean return, and we can look at the coefficient of variation to compare the securities. Then we're going to look at the risk return of a portfolio of two securities and ask, are there any benefits from diversification? Meaning, by combining two securities, does the coefficient of variation improve? Does the correlation between the two stocks impact the risk of the portfolio? Meaning, does the correlation, positive correlation or negative correlation or zero correlation have any impact on the standard deviation of the portfolio and hence the coefficient of variation? The answer is yes. Does the allocation of money between securities, meaning how much I invest in A versus B, impact the risk-return trade-off? Very definitely. We're going to find unfavorable combinations and favorable combinations, and we'll call those favorable combinations efficient frontier, and we'll see all of this later. Let's begin with the two stocks. So here we have stock A and stock B. We can see on the first row, A has a return of 12%, standard deviation of 15. B has a higher return, 15, but also higher risk. The question becomes, which of the two is the better stock? So we can look at the coefficient of variation. Stock A has risk equal to 1.25 times or 1.25 times the return, whereas B has 1.2 times the return. So the risk relative to the amount of return we're getting is smaller with B than A, and a risk averter would be preferring security B. The question is, if we add A to B, can we get the coefficient of variation to be smaller than A? And I said to you before, that's going to depend on one of two things. First, the correlation, and the second, allocation. So let's begin with the idea of building a portfolio and explore correlation first. Correlation has nothing to do with return. Return is simply a weighted average. So it's simply the percent I invest in A times the return of A, plus the percent I invest in B times the return of B. In this case, it's 60% of 12%, plus 40% of 15, 13.2%. I could change that to be 50-50, and then I'd have a new return. And I could change to be 40-60, a new return. So we will see that later when I'm interested in changing allocations. We're going to stay with this one allocation, 60-40. So variance is made up of two parts. The variance is made up of the black part at the top, which is the fraction I invest in A squared times the variance of A, plus the fraction I invest in B squared times the variance of B. Why am I squaring the weights? Anything times the variance has to be the same power as variance. Variance is standard deviation squared, so the fraction has to be squared. Drop down to the middle and you'll see it in black. That first black formula is variance not in common. They have nothing to do with each other. We are going to use that as a starting point for comparison. Go back up to the red row in the upper part of the screen. We see you have 2 times YA times 1 minus YA times standard deviation of A times standard deviation of B. The last thing is correlation of A with B. The way I would want to read this is 2 times the investment in A times the investment in B times the standard deviation of A times the standard deviation of B times correlation. Let's focus on the last part, standard deviation of A times standard deviation of B times correlation. That's covariance. So it's really twice the weights times covariance. I want to keep it in this format so I can change the correlation. So if the correlation is 0, that red term is 0, because everything multiplied by 0 is 0. So correlation of 0 is variance not in common. The minute I make that correlation positive, I'm adding to variance not in common. If I make it 100% positive, I'm adding the most extreme amount to the variance in common. So positive correlation increases risk. Correspondingly, if I make that correlation a negative number, the whole red term becomes negative, and now I'm reducing the variance. The most extreme case would be correlation exactly 100% negative. Then I would bring the variance all the way down to 0. So let's move a little further and illustrate this point. So here I'm going to start off with the correlation of 0 and just substitute in numbers. So the variance of portfolio is going to be 60% squared times the variance of A plus 40% squared times the variance of B. That turns out to be 1.33%. If I take the square root, the standard deviation is 1153. So our starting point is that the variance is 1.33% with a standard deviation of 153. Now let's switch and make it a positive 100% and negative 100%. So if the correlation is 0, I have 0.0133 as the variance. I'm going to substitute at the beginning of the line with 100%. So I have 1.0133 plus 2 times the allocation of A times the allocation of B times the standard deviation of B, A times the standard deviation of B times 100%. Notice the variance doubles. It goes from 0.0133 to 0.0262, almost doubles anyway. If we look at the allocation when it's minus 100%, now we're seeing 2 times 60 times 40 times 15 times 8 times minus 1. You're subtracting the entire covariance formula, and the variance goes to almost 0, 0.000 or 0.03%. So stopping at this point, and if we start at the top, as we add positive correlation, the variance is getting larger. As we add negative correlation, variance is getting smaller. So correlation definitely influences the amount of risk exposure you have in your portfolio. So now I'm looking at a total picture. We see A and B, and we see their returns and risk. And the real question is, can we get the risk below B's 18%? So in the middle of the bottom rows, you'll see I have the return, 13.2, 13.2, 13.2. The first row is 100% in common. Second row is 0% in common. And the last one is absolutely negative, which is perfect opposites. Does not affect return, but it does affect the standard deviations and the variances. So if we go to the variance line, positive correlation increases the variance from 1.33 up to 2.26. Any correlation between 0 and 100% would be some number between 133 and 262. If we look at the negative correlation, it would be the variance would be anywhere from 1.33 to 0.03. So we're going to find that this is really a linear relationship, but I'll show it to you later. Now what I want to do is look at the coefficient of variation. If we look at B, the coefficient of variation is 1.2. Look at positive 100% correlation. The coefficient of variation is 1.23. Because it's positive 100%, the allocations are going to cause the coefficient of variation to be bounded between 1.25 and 1.20. But notice when it's 0 correlation, the coefficient of variation is under 1, and negative, it's closer to 0. So we can see that as the correlation gets closer to 0, the coefficient of variation gets smaller and smaller, meaning you're getting less and less risk for each unit of return you're receiving. Now I want to switch to allocation, and now I'm looking at the allocation from 100% in A to 0 in A. And I'm looking at the returns and simply running from 12% first row to 15% in the bottom. And if we look at the 60-40 row towards the middle, there's our 1320. Had we done 50-50, the return would have been 1350, etc. Notice that from the top of the screen to the bottom of the screen, because I have the smallest return of the stock on the top and the largest on the bottom, it's always increasing. Now I'm going to look at the risk on using an Excel spreadsheet. So I've laid out the formulas. You can see the very beginning is allocation A, allocation in B. Notice I left the allocation A not squared because I want to be able to identify what the combination is. The next column is variance of A, variance of B, 2, etc., etc., etc. Now look at the third column from the right. That's correlation. So I'm doing all these on the assumption the correlation is 100%. And if we look at the standard deviations, like return, they're bounded by the standard deviation of A and the standard deviation of B. Any combination of the two is somewhere between the standard deviation of A and standard deviation of B. Likewise, the return is between the return of A and the return of B. We're going to come back to this. There's no benefit to diversification when you're dealing with positive 100%. Now in Excel, all I did is change that 100% to 0, copy the standard deviations, and then I changed the standard deviation to minus 100% and copied the standard deviations and present them all on the next page or next slide. So here I have 100% in A going down to 0 in A. I can see the returns going from 15 down to 18%. I'm sorry, from 12 down to 15%. If I look at 100% correlation, the standard deviation goes from 15 to 18. Forget about that. Let's go to 0 correlation. Notice immediately the standard deviation declines. 15, 1362, 1253, 1181, 1153, 1172. Well, look, 1153, both directions risk increases, so 60% in A, which is 1153, would be the smallest standard deviation we get. We're going to call that the minimum risk portfolio. So we now know that's the minimum or least risky portfolio. If I go to 70% in A, meaning I go up one row, the standard deviation increases. If I go to 50% in A, go down, standard deviation increases. So in both directions, I take on more risk. But if I go to 70% in A, the return goes from 1320 to 1290. So if I go the direction towards 100% in A, I'm going to consistently get more risk, lower return. Bad thing. I don't want more risk and lower return. If I go in the other direction from 60% in A to 0 in A, then I'm going to go from 1320 to 1315 to 1380. My return is constantly increasing as my risk increases. The question is, does my return grow faster than my risk? And we'll look at that in a couple moments. So the minimum risk portfolio is a 60% in A. If I had negative correlation, then we'd see that the minimum risk is 1.5, which corresponds to 50% in A. So depending on the correlation, the minimum risk portfolio will be a different allocation. And that's one of the things we want to recognize. Depending on the correlation, the minimum risk portfolio will differ. So now what we want to do is take a look at these in terms of graphs. So we can see when it's 100% correlation, it's a straight line. We start at the bottom, which is the 12%, that's stock A, and at the very top is stock B, and as we vary the allocations, it forms an absolute straight line. There's absolutely no benefit to diversification. Where we see benefit of diversification is when it's 0. So here I have drawn in the curve. I'm just looking at the curve itself. So I'm going from the bottom, which is 15 standard deviation, 12% return. And you'll notice if I trace the line, I'm going down, risk is getting smaller and smaller, and my return is rising until I get to the minimum risk portfolio, which we said was 1320. And then as I continue changing my allocation towards B, the return continues to rise as the risk increases. So we're getting more return per unit of risk until we have 100% in B. We call the span of portfolios between the minimum risk portfolio allocation and all in B the efficient frontier. Efficient because it is the better portfolios. How do I know they're better? Let's look at the 12% standard deviation along the horizontal axis. There's a grid line that goes vertically. You'll see the line crosses the grid line crosses the blue line twice, one at the lower point, one at the upper. Means those 2 points in that grid line have the exact same risk, but the upper one has a higher return. Slide over to 13%. Same idea. The upper one has more return, the lower one has smaller return, but they have the same risk. So the upper line is dominant, and we call that the efficient frontier. And the efficient frontier starts at the minimum risk portfolio and goes to 100% in one of the risky stocks. Those are the best combinations. If we allow it to go to negative 0, again, we're going to see a minimum risk portfolio very close to 0. And then the upper part of the curve is called the efficient frontier. Those are all the portfolios that have higher return for the same risk as the lower portfolios. So allocation can be very good or very bad. I could have a 8% standard deviation in this world and have a combination that has a 12.5% return, or it could be over 14% return. Same correlation, just how I allocate my money makes all the difference in the world. So allocation becomes very important in terms of choosing stocks. Here's a summary of the findings we had. The solid black line is perfect 100% correlation straight line. The blue line is 30% positive. Notice there's some curvature. As soon as you get curvature, you're getting benefits of diversification. And there is a minimum risk portfolio. You can see where the curve starts going back to be smaller and then turns to going higher. If we go to correlation 0, that's the blue dash dash dash. Correspondingly, your eye can find a minimum risk portfolio. And when we go with -1, we can see the minimum risk portfolio is where it touches the vertical axes. So this kind of summarizes the efficient frontiers. So what we want to do is go into a little more information about this. First thing we're going to do is find a minimum risk portfolio. Second, we look at the return of the portfolio with more allocation in one of the two securities. So I looked at an increase in A versus a decrease in A. The allocation that increases return shows the direction of the efficient frontier goes in terms of allocation. In the previous example, we went from 60% in A to 0 in A. That's the efficient frontier. So let's look at a tabular form. So here I can see we defined 1153 was the minimum risk portfolio. It's at 60%. If I go to 70%, my risk increases, my return goes down. Go to 50%, my risk increases, but my return increases. So the yellow is all the efficient frontier, including the minimum risk portfolio. So to summarize this or bring this to closure, I called it illustration 1. It's really the only illustration you're really getting. What I can see here is the coefficient of variation. What's interesting is that when I look at the minimum risk portfolio, it doesn't have the minimum coefficient of variation. So if I'm very, 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 very nervous, I probably would want the 50% in A because the coefficient of variation, the amount of risk I'm getting for return, is the smallest number, even though the minimum risk portfolio is the 60% portfolio. But now we can see the coefficient of variations gradually rise until you get to the coefficient of 1.2, which is all in portfolio or stock B.